Dr. B here, and let's have a look at molecular orbitals. What are they? Those are the overlap of atomic orbitals, like s to s, s to p, for example. Here's the major types. If you have a s orbital and an s orbital, that can form a sigma molecular orbital. If you have an s orbital and a p orbital aligning like this is another sigma molecular orbital. If you have two p orbitals and they overlap side by side like that, not side by side, but just one end to one end, this is called a sigma bond. And if you have a p orbital and a p orbital, but they overlap side by side like this, so both things, that's called a pi molecular orbital. Those are the major types. So if it's single bonds, you're going to get a sigma overlap, whether it's due to S or to P. That's a sigma bond. If you got a double bond, there's a combination of both. It's one sigma bond and one pi. So imagine there's your sigma bond and there's your pi bond. If you have a triple bond, you have one sigma and two pi. Then they will be perpendicular in 3 dimensions. They call that orthogonal. So this could be here, and imagine another one in the perpendicular axis, and that would give you the triple bond. Draw them out if you need to. Can that single bond rotate? Yes, it can. If you make a molecular bond, you can see that it does. But if it's in a ring, it becomes spin locked and it can no longer rotate. That has lots of implications. Can double bonds rotate? We'll make a molecular model and find out. You'll see that no, it's just those two bonds prevent it, almost like the two bonds in your arm, if they couldn't do the weird twist that they did, would make it so that you couldn't turn your wrist. What is special about alternating double bonds? Well, that gives you a particular amount of stability. Oftentimes that's due to the resonance structures that can form and spread out those electrons. The bond lengths might be equal depending on which ones you're talking about. That is a very brief look at molecular orbitals.